All right, so let's set this up. We have a ship, here's my ship, is sighted from 2 different radar stations that is 43 kilometers apart. And here is an excellent example of why I have you guys practice things that are not drawn to scale, because you don't know what all these things are going to look like. So just drawing it and then using the information is going to be helpful. So it says the angle between the line segment joining the 2 stations and the radar beam of the first station. So this line and the radar beam is 37 degrees. And the angle between the line joining the 2 stations and the beam from the second station is 113 degrees. I actually drew it relatively to scale, not too bad. And then we're looking for how far the ship is from the second station. So that's what we're setting it up. It's not a right triangle, so we can't use trig or anything like that, but right triangle trig, but I can use law of sines. So I'm going to do law of sines over that one. I'm sorry, sine of 37 over x is equal to the sine of this over this. And that doesn't bother me because I can find this missing angle. I use my triangles equal 180, and I get what? 180 minus 113 minus 37 is 30. So I'm going to cross multiply, and I get 43, sorry, sine of 37 is equal to x sine of 30. Divide by sine of 30, and I do want to make sure we know how to plug that into our calculator. So if we do 43 times the sine of 37, I do need to end that parentheses. Mine opens, some of yours do, some of you don't, but you need to close that off and say, I want you to do the sine of 37, and then after that, to divide by the sine of 30. So it's important to tell your calculator to do the right thing. And x is equal to 51.76. I would round that up because of the 6 there. All right, so let's look at the next one. The next one we have a boat travels 50 miles due west. So we have a boat who's going due west for 55 miles. And then he adjusts his course 25 degrees north of west. So we're adjusting it 25 degrees north of west. So we're adjusting it 25 degrees. And then travels an additional 35 miles. And then how far is it? So we're talking that. So I can do what, sine of 35 over 55 is equal to, this is what we're looking for, sine of, I can find this one instead of using triangles equal 180, these are just linear angles. So I can do what, 155 after I subtract from 180. So 155 over x. Again, I'm going to cross multiply. A lot of 55s. And then I'm going to divide. So again, you're going to plug that in exactly like you did last time and check and make sure you get the correct answer. All right, so number 5. Hopefully you see 30 degrees. If I drop in the 90 degrees, I now have a 30, 60, 90. So if this is 12, this is 6. That means that this happens to be a square. Definitely not all the time, but it is this time. If this is 6, this is 6, and this, that because it's 45, 45, right? And then I multiply by root 2 to get this one. I multiply by root 3 to get this one, and this one is our 6. And the reason that I want all that is for the perimeter, I need to add all this stuff all around. So I'm going to add each of my whole numbers to get 30. But then my 6 root 2 and my 6 root 3 can't be combined. So I just leave them like that. For the area, this is 36 because it's just base times height. Base times height divided by 2 gives me 18. And this one here, when I multiply these and divide by 2, I get 18 root 3. So when I add those together, I get 54, but then I can't combine my 18 root 3 with my 54, so I leave it just like that. All right, our last one is Superman. So I'm actually going to, I have more space on this paper, so I'm going to do it. So Superman leaps to the top of a building, which is 275 feet. With his X-ray vision, so here's Superman, his plate cape, he sees a robber under a bank vault 40 feet underground. So here's ground. Now I need to read a little bit more because I'm not sure what's going on. So it says the angle of depression of his line of sight is 35 degrees. So if he looks straight out, that would be 0. And he's looking 35 degrees down. So we're doing that. And he sees him enter a vault. Here's our little vault, which is 40 feet underground. So we're saying if he flies down in a straight line, how far would he have to fly? So we're talking about this distance of flight is what we're looking at. So it seems to be that we might want to go ahead and draw a nice big right triangle. I think that would be the easiest because I don't know either of those values. But I do know that this is 35, and I do know that therefore this is 55 degrees because triangles this would be 90 degrees there. And I do know that this is 40, so this whole thing here is 315. So I would say, what am I looking for? Close is close. So I would say cosine of 55 is equal to 315 over x. And I'm going to say multiply by x to move that over, and then divide by cosine. So x is equal to 315 divided by cos of 55. So 315 divided by cos of 55 is 549.19 is your answer.